Okay, so I thought I'd go through the rest of the example that we had from in class. I know you looked at it in the lab, but I thought I'd sort of finish up some of the details and then show some analysis using NumPy that you wouldn't have gotten to in the lab. So this is exactly where we were last time. If I run this, I have the lists for the passenger class, sex, and survive. The only thing that we need to do is age, which is a little bit tricky. You probably remember from the lab, this one takes a little bit of thought. If I look back at this string, you'll see that the age follows the sex. And if I count the number of columns, that would be 1, 2, 3, 4, 5. So column 4, if I were separating based on the way that the data is represented here, this would be the whole name. The problem is if I'm using just regular string manipulation, using splits, the easiest thing to do would be to split on a comma. And if I do that, then I get the last name and the first name with the title and all that separate, so that the age becomes the element 5, so number 6, so element 5. So if I do that, try to get the age.append, let's see, the string is line split with a comma, and then take the 5th element. This will run. But if I look at what I get for the ages, there are actually some integers and then some fractions, and you'll see all the fractions are less than 1. Those end up being infants that are 9 months or something like that. But there are actually some ages that are empty. And so we want to skip these. So if I do this, I'd insert a line here, after line, and maybe I'll call it temp age. And so I get this string, copy it over here, turn it into a float because of those fractional ages, and this we're going to see actually fails if I try to run it, because you can't turn an empty string into a float. So first of all, we have to check if this temporary age is actually a number. So if temp age is not equal to the empty string, which is what we would get, then, or even better yet, we could say if temp age is equal to the empty string, we can use that cool continue statement, which just means that we're going to go right around and skip all the stuff down here. So if I do this, I can take this and in its place put temp age, and in particular the float of temp age. So I have all of the ages together. Now if I run this, I should have, temp is not defined, of course, because I called it temp age. Do this, then voila, I should have everything. All of the things should have the same number of elements. I have 1046 for age, 1046 for P class, 1046 for the sex, and for survived. Perfect. That's exactly what we need to do. Now, if I want to compute the average passenger class of those who survived using loops, this is how I would do it. I first need to make a total sum of for the class. So total P class, call it 0. And then I have to create a total number of those who have survived, so total survived, and I'll set that equal to 0. Now I just have to go through both of the lists for the survived and passenger class, and if the person has survived, then I increment the passenger class total. So for I in range, the length of, could be any of them, it just has to be 1046, but I'll use P class. If survived I is equal to 1, then I increment total P class is equal to total P class plus P class I, and total survived, which I could just get by summing survived, of course, but we'll be explicit here, is total survived plus 1. Just increment it if it's that. And then the average P class survived is equal to the total P class that I've added for all of the ones who have survived, divided by the total who have survived. And if I run this, I should see that the average passenger class who has survived is 1.88. So that's a little bit higher. Remember, first class is the top of the echelon, the most expensive tickets. Middle class is a 2, and third class is a 3. So this is actually closer to first class. So if you think about the way the Titanic was organized, the first class had upper decks. They were closer to the surface of the ship, easier for them to get out. All right, we could actually do the same thing for those who have not survived, and just say if survived is equal to 0. Let's say perished, total perished. Change this to perished, change this to perished. I think that's the last one I need to do. If I run this, whoop, total perished equals 0. Try to run this, and whoop, float division by 0. That's because I have to increment that. Now run, and total perished. You can see that on the average, it's the folks who are between class 2 and 3. Sort of makes sense based on the way the ship was laid out. So you can do this for each of the categories. The average class, the average age, average sex for perished or survived. Another way to do that is to use NumPy. And this is kind of a cool trick. If I first convert these different lists to arrays, they're all numbers, right? So let's take P class. Just call it an array. So NP array of P class. Do the same with survived. So say survived is now equal to an array of survived. All right, now see what happens when I do the following. Let's run this little thing here. And if I take P class, P class is just this array of 1s, 2s, and 3s. Now, if I want to select just those passengers who have survived, turns out NumPy gives me a really cool way of doing that. P class, and in the square brackets, rather than doing slicing or indexing, I can put survived equal 1. Okay, so first of all, let's see what survived equal 1 gives us. Survived equal 1 gives me true, true, false, and it's really just an array of trues or falses on whether or not survived is equal to 1, whether or not they survived. Okay, so if I take this and use this as my index argument to P class, it will pull out just those passenger classes for folks who have survived. And if I look at it, it's like mostly 1s and 2s, very few 3s. And if I take the mean of this, NP mean of P class survived, I get 1.8829 blah blah blah, which is exactly what I got using loops. So, kind of a cool trick.